Let me carry on the previous discussion of self-inductance. It is the inductor, the coil, where the current is flowing through it. The inductor, the same as inductor, current is flowing through the inductor. As long as the current remains constant, we don't expect these changes. If the current is varying either increase or decrease, any continuous increase in current or continuous decrease in current in the conductor, we expect the following changes. What are these effects? If the current is continuously increasing in the conductor, as we know, let me recall the previous class. When the current is increasing in the conductor, there is a rate change in the magnetic flux, variation of magnetic flux, which induces voltage. It is also called as EMF or back EMF, and that voltage produces its own current. It is called as induced current. That back EMF will oppose the changes taking place in the inductor. That is, the change means increasing current will oppose the increasing current in the conductor. As this voltage induced in it, and this voltage is an obstacle for the flow of current in the conductor. Obstacle that will obstruct the flow of current. In that case, there, what is that? The system, the work is done by the system to overcome that obstacle, to overcome that difficulty. The work is done by this current. The work is done by this current, and what the amount of work done will store up in the coil as EMF, back EMF. That EMF is also called as energy. That energy will store up in the magnetic field that is produced in the coil. So it is a mere conversion of electric current into energy, which then store up in the magnetic field. That energy is called as magnetic potential energy. It is called as magnetic potential energy. Energy will store up in the magnetic field. So magnetic field is the coil. So it is a conversion. So as long as the current is increasing, there we see magnetic potential energy is increasing in the coil, and the current induced is always in the opposite direction of the flow of current. That is opposing it. That is a change, we see that. So it is a mere conversion of electric current into energy which will store up in the magnetic field. That is called as magnetic energy in this case. Suppose that is here work is done by I and store up as EMF in the field, magnetic field. If the current is decreasing in the coil, reverse happens. If the current is decreasing, this decrease will oppose by this inductor. What is that opposition? That opposition means this flow of current create magnetic field. Magnetic field has magnetic potential energy. Now, work is to be done on the system. The work is done on the current, and energy for the work done, it is come from the voltage, that is EMF already in the magnetic field. Magnetic field is a kind of potential energy. So this magnetic potential energy that is storing up in this magnetic field will be released, converting into current, and that current is flowing in the direction same as the flow of current in the conductor. That will oppose, that means tends to, what is decreasing tends to increase. So that increase in current is come from the energy stored up in the magnetic field. It is a mere conversion of magnetic potential energy into current. Here, the reverse it happens. So this is what the changes we observe when there is a variation of current in the inductor. If this is increasing, converting current into energy. What kind of energy? That is a magnetic potential energy. If there is a decreasing, there is a conversion of the magnetic potential energy into current. See that direction of the flow of the induced current is same as this. So this will oppose the change, and the direction of the induced current, the current is opposite to that, to oppose this change. So this is known as the mere conversion between electric current and energy which will store up in the magnetic field. That is, in the form of work, we see that work is done by the current, work is done on the current. Let us see that work done in the form of mathematical formulations. So it is the work done, I am taking this as the rate of work done, rate of change of work with time. This is also known as power, electric power. As you know, electric power definition, voltage into current. Recall the previous some classes. Electric power is voltage into current. The voltage I have taken here, induced EMF or magnetic potential energy E, and the current is current what is flowing in the inductor I. So rate of change of work dW by dt equals minus E into I. Minus E means, so they are in opposite direction according to Lenz's law. If is work done by the current, here EMF in the backward direction, potential energy increases. If work is done on, potential energy decreases. There is difference, plus and minus here. So this we can use the voltage as voltage. That voltage is magnetic potential energy in the coil E into current flowing through the conductor, inductor. And this we know that minus E equals L into di by dt, because E is, what is minus E? E is the rate of change of magnetic flux. It is same as E, minus E. So minus E is equal to L into di by dt. Recall from the previous class equation. Put that equation into, that is substitution for E, we get this equation. This minus equals this one. And with this left hand side we have denominator dt and dt cancels, remaining is this. Look at this, I into L into I into di. The variables are work and I. The variables are work and I. This is a differential form of equation. Let us integrate this equation. Upon integration of this equals W. Integration of right hand side is this. L is constant. Integration of I with respect to I is I into di is I squared by 2. I squared by 2. So this is the integral form of the equation. Hence W is equal to 1 by 2 into L into I square. Look at that, we have arrived at the mathematical formula for W. What is W here? W is nothing but magnetic potential energy. What is this magnetic potential energy? Is energy stored up in the magnetic field. Where there is a magnetic field, there is energy stored up. That energy stored up is called magnetic potential energy. So W is equal to half into L I square. It is present in this coil. So it is getting stored up here. You are getting release from this. So work is done on this by releasing from this energy. So this is a type of energy that is called magnetic potential energy, the equation. Now there is some comparison between two types of energies in physics. There is one more energy. There is a comparison. This energy is called kinetic energy of mv square. As you know, kinetic energy is energy associated with a moving object. The object has mass. While moving, it has a velocity v. That is, kinetic energy associated with this is equal to half into mv square. And there are some similarities. This is a comparison. These two concepts are fundamental in physics in a system like this. So what is the similarities here? Of L M I square V square. This L is known as inductance, self-inductance. This is also called as electrical inertia here. Electrical inertia. This M is called as mass, and this mass is known as mechanical inertia. Inertia is common, similar. There are appearing two different concepts. Here in electricity, here in mechanics. There is a movement of object. This mass is known as mechanical inertia. This inductance is known as electrical inertia. What is meant by inertia? Inertia meaning is lack of energy. It means inability to change, resist the change. What is the meaning of inability to change, resist the change? That is what we expect. If there is a variation of current, this will resist. Any increase tends to decrease. Any decrease tends to increase by this concept here. That is what I explained. Similarly, we have what is that? Any variation of velocity. Variation of velocity means increase in velocity. It is also known as acceleration. Or decrease in velocity, it is called as deceleration. if you find any such variation, that is increasing velocity, it is opposed by the mass, that is inertia, opposed by the mass, that is mass of the object, mass possessed by the object, mass of the object. Any deceleration, any decrease in velocity which will be opposed by the mass, that is called inertia, mechanical inertia. It is called electrical inertia. It's quite common. So these properties are analogous to each other. Similar concepts are different, but some similarities we see between them. So this is a concept of inertia. Concept of inertia. It is called electrical inertia. It is called as mechanical inertia. This mechanical inertia, the facts are observable in our daily life. Just an example. If a bus suddenly stops, what happens? We fall forward. We fall forward. The reason here, it is the inertia. What inertia? If bus suddenly stops, decreases the velocity. Applying brake will decrease the velocity of the bus. That decrease will oppose by the mass, inertia. Oppose. So this will appear in the form of what is that body continues to move forward even after the bus stops. That is called inertia. Suppose the bus suddenly move. What happens? We fall backward. The reason? Inertia again. So what is that? Suddenly, what is that? Bus moves suddenly, increasing velocity. Any increase in velocity is opposed by inertia, mass inertia. That will appear as the body continues to be at rest even after the bus moves suddenly. That is why you fall backward. So that is the kind of inertia. It is observable in our daily life. There is an example like this. So this is what the properties. What is that? These two energies, both are energies, different types of energies, and there is an analogous between them. That is what I explained it. And finally, when you talk about so much about the inductor, coil of inductor, self-inductance, what is its applications? Applications are numerous. That is one applications in LCR circuits. What is meant by LCR circuits? A circuit, so, is a combination of all these components. Is an inductor like this. L stands for inductor like this. And there is one more component, it is called capacitor. And one more is called resistor. You know all these two. And this is concepts. In a circuit like this, these circuits are used in electrical as well as electronic circuits. Very useful circuits. Because I want to understand the concept of each one component. And these components either connected in series or parallel, depending on what the changes are, what the function you want in the circuit. What is an inductor? I already told you. Inductor is the one which resists changes in current, which will resist variation of current. And any variation will store up. That is actually, as a result, now the current is getting changed into energy. Current is stored up as energy in the magnetic field in this case. In capacitor, recall this capacitor means it is the one which resists the variation of voltage in the circuit. Resist the variation of voltage. resists the variation of current, capacitor. But here voltage is stored up as energy in the electric field. Difference. This device will change the voltage into current stored up in the electric field. This device convert current into energy and store up in the magnetic field. Resistor means, as you know, this is the one will resist the flow of current. Difference, resistor changes in variation of current, resists the flow of current itself and changes the current into heat energy. A form of energy is called heat energy. Look at the differences these components functions in the circuits. And in brief, let me explain the application of these LCR circuits. These LCR circuits used in electrical and electronic devices. Main purpose first is function. Regulator is a current regulator and voltage regulator. Keep the current constant if there is a variation in current, and keep the voltage constant if there is a variation of voltage in the circuit. The main purpose. And also this LCR is very important in telecommunication. This LCR circuit you are finding in all mobiles, TVs, computer because this has a wide range of applications. This LCR, the LCR is the one which selects what is that. There are in the circuit there are number of frequencies, number of different types of frequencies. Different frequencies we have. Among them, some frequencies are wanted, some frequencies are not wanted, unwanted frequencies. So in this case, this is the one which select what frequencies we want. Select the specific frequency, and remaining are removed. So selection is called as tuning circuit. That is, in that case, it acts as a tuning. And filtration. Filtration means the frequencies which are not required or removed. Basically, it is called as filter, act as a filter. And also, the same circuit can act as an oscillator. It can generate frequencies of one particular frequency. Generates the signals, or that is electrical signals of one particular frequency. That is an interesting question, because the circuit can generate any number, that is mixture of frequencies. If you want one particular frequency, it is the one can generate that particular frequency of the signal. So it is called an oscillator. So this LCR can act as a tuning circuit, a filter and an oscillator in the electronic devices. So these are, I think, only briefly I talked about this. That is LCR circuit. Mainly it is a combination of these three components. So these are either connected in series or parallel to have one particular type of function in that electronic devices. So that is application of inductor or self-inductance. So this is what about, that is a theory about the self-inductance and the function of the self-inductance. How does it work and what happens during the current flow, and some similarities between the two types of energy, and finally the application of this inductor. This we are finding in LCR circuit. With this we have completed. Thank you very much.